Okay, so hello everyone. In this video, we'll be showing the question number 3016, which is the minimum number of pushes to type a word, part 2. The question is marked medium. It is easy to understand. It is just a small, twisted version of part 1, and we'll just find that approach, the required thing to solve the question. So, yes, let's first understand the question, examples, and then we'll solve the question using two approaches. So, yeah. So, what the question wants to say is that we are given a string word, okay, which consists of lower English letters, and telephone keypads have keys. We have a distinct collection of lower English letters. Okay, so suppose we have this key 2 over here, it has AFC, and you can see that there is no other key which has a same collection of key of words. 5 has different, 9 has different, so all these 8 or all the keys consisting of the characters have the distinct collection of English letters, and we need to form words by pushing them. Okay, if the key is mapped with ABC, we need to push one time to type A, two times to type B, and three times to type C. Okay, if we want to form A over here, we need to push this A key one time. If we want to push or type F, we need to push this key two times. And if we want to form the word letter G, we need to push this key three times. Okay, that's given. What is, we are allowed to remap the keys number 2 to 9, distinct collection of letters. Okay, so this arrangement of letters can be remapped, and we can remap from 2 to 9 only. Okay. The keys can be remapped to any amount of letters, but each letter must map to exactly one key. It means that if suppose I have used T in this key, there are similar, no other key or T cannot be part of any other. T can be part of only 8 in this case. If E is used over here, E cannot be part of any other key. And if this key has 4 letters and this key has 3 letters, it is still a valid combination. Okay, we need to return minimum number of pushes needed to type word after remapping the keys. So we are given a word and we need to remap the keypad as per requirement. And 1 asterisk hashtag and 0 does not map to any letter. So we can say that 1 asterisk 0 and hashtag do not have any letters. Okay, so yeah, let's first take one example and understand what we are supposed to do. We have AA word is like AA, BB, CC, ED, EE, FF, GGHH, and yeah, let's take one more character and I, which is 67345 6. Okay, so what we did in the part 1 was we first filled all the keys. We first filled all the keys in which the relative order did not matter. So if we try that here as well, and we put one I over here. So now let's calculate the minimum number of pushes required. We see that A is 2 times, and it will require one push over here. So it will require 2. Likewise, all these are on the first. B is also first. Is also first, so it will require 2 pushes. C is also first, like this. All these will require 2 pushes. Now we can go to 6. I, it has 6 occurrence. And we found that it is at second index. So it will for one I it will require 2. And likewise for the 6 I's it will require 12 pushes. Can this be minimized? Yeah. Suppose what we have done is, if we have put I on the first and A on the second, it would have been beneficial. Like, why? What would have happened is, this A would require 2 push. So as a result, these two A's will require 4, and this I will require 1 push. So these 6 I's will require only 6 pushes. So 6 plus 4 12, 6 plus 4 10, and 12 plus 2 14. So we have reduced 4 pushes. Okay, so what we have found is that we try to prioritize those characters with higher frequency, and as a result we will require a map to store frequency. Okay, after prioritizing we do the same as in part 1, like fill 8 keys each with one character, and then we move to filling the 8 keys with 2 character. Okay, so how we will do is, our approach would be, here in this case we will use map to store frequency, but after mapping what we will do is, after mapping we will sort the frequencies. As a result, higher frequencies will turn up faster, what you can say first, and as a result we will assign them. If it is in top first 8 characters, it will require one push, and in total it will require 1 multiplied by frequency. Okay, if it was in like the next 8, it will require 2 pushes for each character, so it will be 2 star flag. So as then we can return the answer. So let's move to the implementation part. What we'll do is first declare the map, which is in this case we will use unordered map because we just want the unique elements. We do not want any sorted order of, what you can say, characters. And now we will iterate the map word using for each loop. For this is called a for each loop. So the frequency will be increased by 1. Now create an array to store frequency. Okay, vector int v, and we'll push all the frequencies from the map to array. We will use iterator, which is start from beginning till the end. And we increment iterator. Iterators are nothing but pointers. So the we have stored it in character to frequency. So the frequency is the value part. So int frequency is nothing but star it dot second, and we'll push it in the B. Okay. Now we will sort it in the descending order because we want the highest priority first. So how we sort in the descending order is, we use R begin, which is in reverse, and Rn, which is reverse. Okay. We will use answer operator, answer variable to return, and counter to check if it is in first 8, second 8, or third 8. We initially put counter to 0 because we have not encountered any number yet. Now we iterate the frequencies, we increment the counter because we have encountered one of the numbers frequency. If count is less than equals to 8, answer plus equals to, what is the answer? Yep, value, which is nothing but frequency multiplied by 1. It will require only one push. If it is in another 8, so it would mean that count is less than equal to 16. And what is count? Number of what you can say, characters encountered so far. Answer plus equals to, well, start to, it will equal to pushes, and if is equals to 24, answer plus equals to L start 3, and for the remaining it will require 4 push, and we know that there are only 26 elements in the alphabet. And now what we'll do is return the answer. Okay. Okay. Instead of error, we could have used max heap as well. So it will still be the same because sorting will require O of n log n. And if we use max heap, the iteration will take O of n, and the insertion will take O of log n. So it will still be the same because we will iterate, and while iterating we are pushing, so it will still be the same time complexity, and the space complexity is constant because we are using at max 26 characters, 26 space. Okay, so I hope you guys understood. This time, instead of just simply counting the first eights, we count the frequencies, and the ones which are in the higher frequency range, we use them first, because if we put the higher frequency characters later in the keypad, like in the second index or the third index at a particular key, it will require more pushes, and that pushes would increase as the frequency would increase. If one has 4 frequency and it would require 1 push, so total would require 4 push, but instead it is at third index, it will require 3 into 4, 12 pushes. So the numbers or the characters with the higher frequency, we put them first. As a result, the minimum number of pushes are acquired, and yep, time complexity is of n log n, whether you use sorting method or a maxi, and the time space complexity is also of n log 1, because maximum we are using 26 character space. Okay, so if you guys any doubt, do let me know. And yeah, thank you.